So in this video, we are going to discuss about height versus node of a AVL tree. Height versus node of AVL tree, right? Sorry, height versus node of AVL tree. AVL tree. Okay. Now we need to find the maximum node. So let me give the maximum node formula. That means if you need to, and another assumption let me make. So height will start from what, 0, right? But here let us make let it start from 1. So you can assume even that as a level, right? A level will start from 1. So imagine height will start from 1. So at that time, so maximum nodes that can be used in order to make a AVL tree of height h, provided that height start from 1, is 2 power of h minus 1. This is important. 2 power of h minus 1. So okay, now what is the minimum number of nodes? Minimum number of nodes is what is its formula? It has a some three formulas, right? There's some three formulas. So let me explain you how we get that one, how we can reach to that one. So imagine h is equal to 1. Since h is starting from 1, so with minimum nodes, how can you draw AVL tree? Okay, you will draw like this. So number of minimum, this is, I am talking here, n means I will be talking about minimums because I already talked about maximum, right? So this is 1. Nodes, number of nodes required is 1. So if h is equal to 2, so if h is equal to 2, I will draw like this. So first of all, check whether this is AVL tree or not. For that df you need to check, right? Balance factor. Here it is 0, here it is 1. So here it is AVL tree. So number of nodes that you need is what? 2, right? Okay. Now for h is equal to 3. So for h is equal to 3, you should draw like this, right? But here bf is 0, here bf is 1, here 2. So here we have 2. That means it is not a what? AVL tree. So for that, what I will do? I will add another node here. So it will have 2 minus 1, 1 bf. So it is a AVL tree, right? So what is the minimum of number of nodes I need? 4 nodes I need. So let me take another last example, and I will explain you completely how it works. So h is equal to 4. When h is equal to 4, you definitely need to reach till h is equal to 4, provided that height start from 1. So here it is 0, this is 1, this is 2. So it is becoming 2. How to make it as 1? Simple. Simple. Add one node here. So if we add 2 minus 1 is what? 1. So okay. Now again, here how many height is what? It is 1 to 3 minus 0. It will become 3. So in order to prevent that, I will add 2 nodes. Now what? 3 minus 2 is what? It is 1. So it is AVL tree. So minimum number of nodes required is 1, 2, 3, 4, 5, 6, 7. 7. So let me make a table for this. For h is equal to, for n, I am talking about minimum. Again, minimum, I already know the formula for maximum. You just remember that thing. So for minimum, for h is equal to 0, for h is equal to 1, 2, 3, 4. It is 1, 2, 4, 7. Let us make some relation. Let us establish some relation. For 5 and 6, it is so much, it is impossible. It is so much rather difficult to find n values for increasing h value. So we need a formula, particular formula. So imagine, right? Like what I am going to do is for what is the minimum of nodes that I require, right? So imagine n of h. It is a function. What this function gives? It gives me number of nodes that are required to form height, right? To form height. So imagine for 0 it is 0. And to make uh, so to make height of 1, how many nodes? So in order to reach the height 1, here what I am talking is height. So in order to reach height, that means I'm starting from which node, which height? 1. So for height 1, I required one node. So here we have discussed. Imagine I need to reach 0th height. That means, as I said, height will start from 1, but here they have given 0. That means you are not using node itself. You are not using node itself. There is nothing. You can take it as a nothing. You are not using any node to represent this. So it is 0 number of nodes. These are nodes. Number of nodes. Minimum number of nodes. So for 1, you have seen here we got 1. Okay. For otherwise, what I am going to do is I will do n of, this is recursion, h minus 2 plus n of h minus 1. So for height, otherwise this is the formula. So let us check whether this will work or not. So we know for 0, we know for 1, right? For h is equal to 2, let me check. For h is equal to 2, I will take n of 2 minus 2 is what? 0 plus n of 2 minus 1 is what? 1. So n of 0, I already know that it is 0. Okay, 0. N of 1 plus 1. So you will get 1. So let's see the answer. Answer is what? Answer is 2. So let me add 1 here. So let me add 1 here. I think this is a formula. Let us check for other thing. So again, here I need to add 1. So this is a formula actually. So plus 1, this is what? 2. Now imagine n is equal to 3. What I need to get before that only I will tell you. I need to get 4. And even here also we saw we need 4, right? So h of n 3 is equal to n of 1 plus n of 2 plus 1. For n of 1, it is 1. For n of 2, it is 2. So you saw here 2 plus 1, it is what? 4. So what we needed to get, it is 4. And for n h of h is equal to 4, let me do last thing. For n is equal to h is equal to 4, that is function of 4 will be equal to n of 3 plus, that is n of 2 plus 1. N of 3 I know, that is 4. 4 plus n of 2 I have done here, that is 2 plus 1, that is what? 7. So you are getting 7. So if you run this function for this recursion, then you will get for all the values. So this is for what? This is to find minimum number of nodes. This function I need. So to find the maximum number of nodes, you need this one. So let me write here also number of, again 0. For 1 it is 1, it is n minus 1. So there is n of, right, that is n of h minus 2. So you can write this here. You need h of h minus 2 plus n of h minus 1 plus 1. Otherwise when it is n of h, I needed to find. Okay, now what if h starts from 0? So when h starts from 0, I will modify this formula as h plus 1 minus 1. So if h starts from 0, I will do this one. So this is the formula if you want, if h is starting from 0. So this is when h is starting from 1. So let us focus on when h is starting from 1. So let us find. Now I have found the relation between node and height. That is node in terms of height. So let us find height in terms of node. For that, I'm just going to copy this everything here. Then again, find maximum number of nodes is nothing but n max. N max will be what? It will be 2 power of h minus 1. So send minus 1 here, n plus 1. So let me take it as n, just n. So h will be what? H will be this? No. But here there is 2, right? 2 is a power here. 2 is a power here. I will send 1 here. Then here 2 power of h I have. So log base 2, right, is equal to h. Is this a formula? Yeah, this is a formula for h in terms of n, right? Now it is n max, right? So for n min, what you are going to do? So n min, what I am going to tell is, by looking at this table, if number of nodes are greater than, so greater than equal to 4 and less than 7, then maximum height is 3. Right? Maximum height is 3. So I can tell like this. So this is actually for minimum height. As I said, for if you are finding a relation between maximum node and height, then if you reverse this, you will get a relation between minimum height and nodes. So you are getting for h min. So for h max, so if number of nodes are 4 to 7, then my maximum height is 3. So if number of nodes are from 2 to 4, then maximum height is 2. So this is how it works. So here what we actually get is 12. So if number of nodes are greater than equal to 7 and less than 12, then the maximum height will be 4. So this is how we are going to solve AVL tree. Now after this video, I will end this AVL tree videos, and I will add 2-3 trees. The videos next what you are going to see will be 2-3 trees which are useful for database. So if you have any concept you need clarification, you can check out this channel and you go to the playlist and you can see the tree playlist. There you can find all the topics. So thank you for watching the video.